To start. Hi everybody, and thanks for joining today's CPD, which is about basement waterproofing and the associated standards and solutions that are available in the marketplace today. My name's Dave Tilford. I'm a CSSW accredited specification manager for Sika waterproofing. We also have James Clark and Pete Cowan present in the CPD today. They both have a great deal of waterproofing and concrete knowledge. They'll be manning the chat box, which you should be able to see on the right hand side, should you have any questions throughout the CPD. Now, if there are any questions that we can't answer today through the process of the CPD, we will be able to get you the answers and we may need to come back to you with those. But pop any questions in there. There'll also be some time at the end of the presentation for some questions as well. Okay, just going to turn the camera off now, just for distraction purposes. Okay, so CPD content today. What are we going to go through? We're going to have a look at an introduction to Sika, give you a bit of information about who we are, kind of the foundation of Sika, and what we do, which is a little bit different to others. We're going to look at the Get It Right initiative and how it makes such a dramatic change in the industry. We're going to talk through reference materials, what documents are important, and what are we looking at when we need to kind of make decisions and find guidance on waterproofing. We'll look at waterproofing strategies, design process, and also systems and selections of materials. And then at the end, we'll go through a conclusion and we'll have any questions, just as a bit of a wrap up. Okay, so you perhaps know Sika is a global leader in construction chemicals and materials, but it actually started from humble beginnings in 1910. Caspar Winkler was working on the Gotthard Tunnel project, and he realised not only was there a need for waterproofing mortar additives in the project, but it was also required in Europe and later around the rest of the world. Over the years, as the company diversified and grew at an astonishing rate, it hasn't though always been plain sailing. When the economy overheated in the late 60s, Sika slid into serious crisis and only just managed to avoid insolvency. But the team pulled together and then the Sika spirit was born and strengthened. The solidarity, the personal responsibility and the optimistic attitude put them back on the right track to the future. The Sika spirit actually still makes up the DNA of the company today. Sika Limited and Sika Ireland Limited are part of the global Sika group. We specialise in the manufacture and the supply of chemical-based products. Sika's got a leading position in the development and the production of systems and products for bonding, sealing, damping, reinforcing and protecting in the building sector and in the motor vehicle industry. We have subsidiaries in over 100 countries around the world and we manufacture in over 300 factories. We've got more than 27,000 employees and Sika generates annual sales of just over 7.5 billion a year. We're also committed to providing quality, service, safety and environmental care. So a bit more local, in the UK and Ireland, we provide market-leading solutions for concrete, waterproofing, roofing, flooring, refurbishment, sealing and bonding and industry. We have manufacturing sites in Welwyn Garden City, Preston, Leeds, Wishaw and Dublin. We've got over 1,000 UK employees and we turn over more than 360 million. So our solutions, well, the product that Caspar Winkler started with in 1910 is still used today and it's called Sika One. So today Sika is a large global organisation, as I've mentioned, and in the UK we run as 8 separate target markets to be able to support our customers. You might be familiar with other Sika brands such as Sarnafil, Trocal and Everbuild. So we pride ourselves on innovation, customer service, and we're here to support your needs through every step of the project. The Get It Right initiative. Now this is something that's really key. The Get It Right initiative was produced and it's a report in 2016 that looks at how to improve the construction industry with the aim of, well, of course, getting it right. Research shows that the construction industry could save between 10 and 25 billion pounds per year just by eliminating errors. Certainly worth a read for those who are not familiar with it, and it's a great document to get some details from. Now, really interestingly, the report ranks areas of work according to their financial impact should an error occur. Now, as you can see in the table, basement waterproofing was one of the most significant areas of work. Now, when you actually combine this with the fact that waterproofing is heavily linked with the concrete works, which is actually the #1 error, you can soon appreciate how high risk basement waterproofing is to construction professionals and contractors alike, and therefore how important it is to get it right first time. In order to get it right, all of the stages need to be considered carefully. This means from site assessment right through to any maintenance or commissioning required. We will touch on that a little bit more later. One of the critical elements of getting a project right is to have a clear, defined understanding of the lines of responsibility when it comes to the design of the waterproofing stage, whether this lies with an architect, an engineer, a contractor, or even a specialist waterproofing designer. But all these are absolutely key to getting it right. So when it comes to correct specification and detailing, like many aspects of construction, the devil is about the detail in waterproofing. In our industry, we talk about the 99% rule. You can get 99% of the waterproofing correct, but it's that 1% that's incorrect that's going to lead to problems occurring at a later date. It's really important to have a full understanding of the site. And there's going to be a few key elements that we'll talk about over the next few slides that we really need to get to grips with and understand to make this happen. So while the waterproofing design may be robust, you still need to rely on the correct installation. The vast majority of systems are installed in situ by human beings, and errors and omissions do happen. It's therefore important that an on-site waterproofing strategy is formulated. One area that dramatically reduces errors and emissions on site is by having a waterproofing technician and or a CSSW qualified person to attend the site during the construction. That person could be there to look how to stop these errors at source and offer support and guidance. So section 7.1.5 of the new British Standard recommends the selection of a competent waterproofing contractors with appropriate cover during installation. Here at Sika, we provide training to installing contractors to the correct level of competence that's required. Reference material. So when it comes to reference material, there's two main documents that we tend to look at. There is the British Standard, which, apologies, I will kind of repeat that over and over through the presentation, and that's called the BS 8102. And then there's also the ICE document which is the Institute of Civil Engineers. Both are really important and they do go through some quite different things, but both are worth having a look at for reference. So the BS 8102 has recently been updated into a new document, which is more comprehensive and it's more relevant to today's industry. There's some significant improvements and clarifications for being able to devise a successful waterproof strategy, and it's got a clear philosophy for establishing the responsibilities of the whole design team. And just making sure really that communication flows well throughout that. It also now addresses protecting structures from all water sources and not just groundwater. The BS 8102 outlines in figure 1 from the Code of Practice that the principal factors and stages that need to be addressed in order to produce a robust waterproofing solution for the below ground structure. It has changed from the 2009 standard to include clarifying the design life of the structure, ensuring continuity is managed, installation is practical, and then discusses the need to commission and maintain some types of system. Just as kind of an addition, throughout the slide, any changes or additions to the new BS 8102, the 2022 version, you'll actually see highlighted in yellow boxes throughout the presentation. The initial information requires a design team to be formed. So this should include a geotechnical specialist to help with the site investigation, of course, and then a waterproofing specialist. Now, the waterproofing specialist in the majority of UK design teams is the manufacturer or a CSSW qualified person. Some of the UK leading insurers, such as the NHBC and Premier, are now insisting that the design team also includes somebody with the CSSW qualification. This is a certified surveyor of structural waterproofing. An important thing to note for the design team is that specialist guidance and advice should be provided by a suitably experienced person for the type and the size of that project. Once the design team is formed and the site investigation has taken place and the details are there for that, it's crucial we look at the above items. Things such as the water table, the soil type, is it free draining? Is it going to cause a kind of any purchased water tables or anything like that? Are there any ground gases on site? All of this is going to have a dramatic effect on what level of the attention to detail we need to pay to the waterproofing for the said project. This CPD is about waterproofing, but it's also worth noting that Sika offers a whole selection of gas resistant products. Again, knowing about any kind of ground gas is key information for us to know at the earliest possible design stage, so then we're able to incorporate this into the waterproofing line of defence where and when necessary. One of the really key things to consider, and something that can be often missed, is actually the client's requirements. BS 8102 categorises areas in certain grades of waterproofing, but the actual requirement from the client and their expectation could actually be very different. The key questions above are pretty much key to determine what's expected and what's required from both sides. When you're considering the grade, you also need to think about, will the use of this space change in the future? It's often easier and more cost effective to design the waterproofing for a new build project to a kind of a future or a higher upgrade, rather than go back at a later date and retrofit another product or line of defence. For an example, a below ground car park is often classified as an area where a minimal amount of water penetration or damp would be deemed as acceptable. And again, this is a key area for kind of getting clients' expectations. The client could actually be building a bespoke home and have a collection of expensive cars, and actually they want a fully finished, dry, heated and ventilated space where there's no water ingress or moisture vapour. So what you could propose and put forward and what the client's expectations are night and day, that they don't match up with each other. So again, it's worth understanding what the client's requirements are and being able to put that into the design and guide them to the correct solution. Unfortunately, we do have to talk about the consequence of failure, and nobody likes to. With waterproofing, we take a very, very pessimistic approach, and that has to be taken. We have to design everything based on worst case scenario. The consequence of failure can be, and often very, very likely is, a very, very high cost. So the BS 8102 states we must consider that water will be likely to bear on the structure at some point during its life. Defects in the waterproofing must be expected. The consequence of water ingress must be assessed, and repair or remediation should be possible. Also, it's worth noting that defects caused by follow-on trades and site operations should also be considered. It's quite common for people to be unaware and then almost drill through an area or penetrate a layer of waterproofing and damage that and kind of break almost the how waterproof that building is. Again, these could be repaired, but that has to be taken into consideration. So what are these grades of basement then, as per the BS 8102? So it's recently got a new grading system as per the BS 8102 2022. Grade 1 has now been split into two different types of acceptable internal environment. As previously mentioned, though, it's vitally important the client is consulted to determine the grade of basement required. Grade 1A is often used for things like car parks, plant rooms, workshops that have got no electrical equipment in them. And a grade 1A space allows for groundwater to penetrate a building, which ideally would be managed with local drainage. And as you can see on the picture, there is water penetration and amount of seepage has occurred. Now, grade 1B, again, can be used for things like car parks, workshops and plant rooms. But grade 1B is a slightly better space in which only damp transmission from the ground is acceptable, but no running water or active leaks are. As you can see, there is a slight but very noticeable difference around the water floor joint on the picture above. A grade 2 area only allows for damp caused by condensation and not from any external water sources. These areas will have unfinished walls and floors, so no plasterboard and carpets and things like that. And this is classed as a damp environment. Often used for things like retail storage, of course, dependent on what's being stored, plant rooms and workshops that include electrical equipment, and often lift shafts as well. So although nowhere is ever totally dry due to aspects such as, relative humidity and such, grade 3 is classed as a dry area and no water ingress or moisture vapour is tolerable. This is often a habitable space, so for things like residential, offices, gyms, hotels, and so on. The important part of a grade 3 space is that heating and ventilation will be required. The risk of the site, the client's requirements, and with the BS 8102, all of that combined will decide the attention of detail that we need to pay to the waterproofing measures and the grade of the area that we need to achieve. The grades are actually covered in more detail on table 2 of the BS 8102, so if you need any clarity, this is a great place to look. This table gives you guidance on how to qualify damp and seepage levels, as this really is often subjective, and it advises that the grade requirements again are discussed with the client at the earliest possible stage for clarity. So the ICE document, the Institute of Civil Engineers document, provides guidance and helps when considering the consequences of failure. It looks at things such as damage, loss of rent, reduction in value of the property, disruption for businesses and things like that. Now, although it was published in 1990 and some of the parts are based on the older BS 8102, it does really still contain some very good information. So moving on to types of protection. Once a grade of basement has been established, you'll need to consider the type of waterproofing you'll use to achieve the water tightness level that you desire. BS 8102 defines types of waterproofing into 3 categories. Type A, a barrier membrane, often known as a tanking system. Type B, which is structurally integral protection, and type C, drain protection. We'll look at all these types in detail shortly, and we'll go through them all. When considering the type of waterproofing to use, one of the most significant parts of BS 8102 should be referred to, and that's Table 1. Table 1 gives the suitability of the type of waterproofing for different risks associated with the water table and the risk associated with the project. As you'll see, for some high risk areas and certain types of areas, that certain different types of waterproofing are not suitable to be used on their own. Therefore, combining 2 lines of defence may be required. Waterproofing is all about reducing risk. I apologise in advance, you'll hear me repeat this multiple times. 2 key areas that can be used to reduce risk where possible are the use of combined waterproofing protection and using reinforced concrete with water resisting admixture such as Sika watertight concrete. And that's as per Table 1 of the BS 8102. So the water table is actually classified into 3 sections. Low, where the water level has been proven to consistently be under the underside of the below ground slab. This is quite rare to see though, as it needs a full 12 months monitoring, which is costly, massively affects time schedules for a site, and often this is categorized as something else. So there's variable, where the water table will actually fluctuate between the underside of the slab and above it, and high or perched, where the water table sits above the underside of the slab consistently, or pockets of water sit above the underside of the slab, causing an exposure to hydrostatic water pressure. This is often down to soil type and such like, and drainage as well, which is really important when it comes to waterproofing. So to add to that, when it comes to waterproofing, BS 8102 states we must expect the design for water to the full height of retaining ground during the life of structure. A lot of people come to us and say, we actually don't think we need any waterproofing because the water table sits 40 meters below the underside of the slab. But again, as mentioned, we have to design to worst case scenario. And again, we have to look at designing, and we must expect water to be the full height of the retaining ground. We have to expect things like a possible burst water mains. And again, this is all documented in the BS 8102. As mentioned, combined protection is now a common occurrence, especially for grade 2 and 3 environments. BS 8102 says that if the risks are high and the consequence of failure, which would of course be water ingress, are unacceptable, a dual system approach should be considered. Some warranty providers may have their own requirements and criteria, and these often exceed what's set out in the BS 8102. So again, it's key that we know that they're involved at the earliest possible stage in the design. It's worth noting that flotation forces also need to be taken into consideration. If the slab is of unknown construction, such as thickness and whether it's supported or fixed in place, there is a risk that hydrostatic pressure could cause the slab to crack or rise, and this would adversely affect some types of waterproofing protection. So a different or more suitable layer of defence would need to be used. It's worth noting as well that NHBC, Premier and other insurers now insist on combined protection for grade 3 basement conditions and high risk areas. Here's a list of just a few other considerations we need to take when assisting with a waterproofing design. The key thing here is to note that every single project is individual. It's all down to things such as location, soil, ground gas. So each project needs to be designed individually and a copy and paste approach not taken. It can sometimes be a little bit of a strange industry to work in, because it's not often that you find that if a project is duplicated, let's say there is a block of flats built, if that's then duplicated, often with a lot of other areas of construction, it can be a copy and paste. But if you were to build the exact same block of flats 10 miles away, there would be different ground conditions, different soils, possible different water table, possibly ground gases and other things like that. So again, a bespoke approach would need to be taken for every single project, even if it's identical to something that's just been built or previously. Okay, so we're going to look at type A pre-applied waterproofing membranes to start with. Pre-applied membrane system is where the membrane is placed on the blinding or in the shuttering before the pouring of in situ concrete. When the concrete is placed, it bonds to the membrane, essentially. This is referred to as a fully bonded system. As this is fully bonded to the concrete, you remove the risk of any lateral water tracking, and again, this reduces risk in the waterproofing design. So why should we prevent lateral water tracking, and why is that important? So lateral water tracking is where water ingress gets through the membrane and tracks behind that, perhaps from an area of damage, maybe in follow-on trace, something like that, and it manages to track fully behind the membrane. Now, water is always going to try and find the path of least resistance, and if it's able to find a way through the concrete at any point, through maybe a crack or a joint, this won't represent where the water ingress actually started. Therefore, repair work can often end up diverting water ingress somewhere else. If water can get behind the membrane, you could find it 10 meters or even further, kind of where it's got through the concrete. Fully bonded membranes reduce this risk massively, and they're tested accordingly for this as well. So again, remediation is a lot easier if that's ever needed. Fully bonded type A membranes are suitable not only for waterproofing, but also for things like concrete protection, where aggressive ground conditions are present. They can also be used for both water and gas protection where required. Of course, that's material dependent. So again, that's why it's key for us to know ground conditions and ground gas at the earliest possible stage. Sika strives to constantly look for new technology and invent new products. With this in mind, we've recently launched Sika A+. As you can see here, with the current SIKAPROOF A range, we have 5 membranes and 2 different tapes. Not only have we changed the technology, but we've also managed to reduce this to just 1 membrane and 1 tape needed for a project. This simplifies both detailing and installation, which ultimately, again, reduces risk. And this can benefit in terms of time saving and cost savings. We say if a detail is complex on paper, it's going to be complex to install on site. So less products are required. And again, this is going to reduce the risk. So here's a video showing the time difference between the installation of the standard SIKAPROOF A08 and the new SIKAPROOF A+ membrane. So as you can see, in and around a 30% reduction in time, which again is going to reduce costs also and simplify the design and installation. SIKAPROOF A Plus can be used as a single replacement for our pre-applied and soon to be post-applied SIKAPROOF membrane systems. And as well as being highly flexible and actually part of the structure when installed, it has a unique patented hybrid bonding layer. So this technology is in the simplicity, and it just shows how Sika are always looking for new ways to improve some already great products. The membrane features the new bonding mechanism, and this provides both a mechanical and an adhesive bond to the concrete, further enhancing the anti-water tracking properties of the system. There is a layer of fleece-based area on the membrane. The fibres bond with the concrete, and then there's an adhesive layer that also forms a secondary bond, making this incredibly robust. So moving on, another type A system is what's been often referred to as a geosynthetic or bentonite clay liner. This is actually now called an active core liner as per the BS 8102. So this is a 6 to 8 mil thick membrane, which encloses a layer of sodium bentonite clay granules. Now, when this bentonite comes into contact with water, it reacts and expands, therefore plugging any possible route for water ingress. Now, bentonite systems are often referred to as self-healing membranes. Should be noted that these are typically used on your lower risk structures, but they're also great for being placed directly against the contours of concrete piles without a need for shotcrete or for facing them. And then we're also going to look at post-applied waterproofing membrane systems. So this is where a concrete wall would be cast, and then a membrane system with a primer would then be placed after the shutters are removed and, of course, the concrete cured. So pre-applied membranes are not always possible for all scenarios. Therefore, post-applied membranes can be an option. This is especially the case when it comes to things like toes around basements and also precast elements. Just as a bit of a caveat, for podium decks, we do recommend a fully bonded liquid waterproofing system. Now, when using a post-applied membrane, surface preparation is absolutely key. And also you need to take into consideration weather and climate as well. That can play a part. Also, just to let you know, a sealer primer will need to be used for these. Loose laid systems are not that common in UK, and they're only typically used where performance levels are extremely high. I mean, a recent example of projects choosing this method are things like Hinkley Point Power Station, Thames Tideway, and HS2. Now, the principle of such systems is to create compartments, typically 200 meters squared, kind of in and around that. And you do that by welding PVC water bar actually to the membrane. Then, should a leak occur, the compartment can be injected via injection ports, meaning the issue is totally isolated to that area and then resolved. The membranes are typically PVC, and therefore the life expectancy of those is in advance of 100 years. So it's really appropriate where long design life is needed as well. They're also very effective in extremely aggressive ground conditions. At Sika, we have specialists that focus on certain areas of construction and specialist items. I'll have the details at the end of the presentation for you to take down if required. And liquid membrane systems. Sometimes sheet membrane systems in their entirety are not appropriate to waterproofing a certain element of a structure. This is typically in refurbishment situations or where a sheet system doesn't meet the construction method. This is where liquid waterproofing solutions come into their own and can be used. So for small areas, this can be hand applied, but for anything over, I would say circa 200 meters squared, then using spray applied membranes is very advantageous as it reduces program times. Now, the technologies used in spray systems can vary, but the highest performing and most popular in the UK now are based on polyurea membranes. Liquid applied membranes are a common choice also where a lot of detailing is required. So with a sheet membrane, you'd have a lot of joins, a lot of details, a lot of patches and things like that. And again, that's that's creating risk. Any kind of joint or anything like that is kind of adding an element of risk. With a liquid membrane, you'll actually create a seamless system, so you're reducing risk at this point. But the real key element of liquid membranes is the preparation and installation. Now, preparation before they're installed will have a dramatic effect on their performance. We can provide details and requirements on this, as well as also recommending specialist installers. and then multi-coat render systems and coatings. As our Sika One render systems a specialist high-performing product, this is managed by our render product manager. Again, the details are at the end of the presentation to offer any advice and support where required. So multi-coat render systems are recommended for high-risk applications according to BS 8102. Render systems lend themselves largely to refurbishment situations, and as they're placed on the internal face of the structure, they can withstand negative water pressure. Positive water pressure would be where it pushes against a membrane or a waterproofing layer of defense and pushes it onto the substrate. So an external membrane would have water pressing against it, pushing it onto the concrete wall. And negative water pressure is where something or water pressure is trying to actually kind of pop that membrane or burst that membrane off of the wall. So an internal application. Multi-coat render systems can withstand negative water pressure, which is very useful. Okay, these systems have a long track record, of course, since 1910, and they last the lifetime of the building, as noted on the BBA certificate. There are specific build-ups for the floor and wall, respectively. And in our waterproofing range, due to the install process and the warranty provided, this is one of the only products that we allow only to be installed by an approved specialist waterproofing installer. Again, this is just for guarantee purposes to make sure it's installed properly and gives you the correct protection for the area that you've got. To reduce risk and ensure quality, the correct dosing on these systems, they're pre-bagged, and this guarantees the application, reduces risk and reduces failure. Key consideration is to evaluate the possibility of any movement that could occur at maybe like a floor to wall joint or a wall to wall junction. Especially for refurbishment projects, these areas are therefore treated with CombiFlex movement joints as shown. We do actually have a separate CPD on Sika One render. If that's of interest, again, our render manager's product details will be at the end of the presentation. Type B solutions are known as integral waterproofing, which is where the structure itself provides the waterproofing line of defence. The BS 8102 recognises 3 different methods of waterproofing for Type B systems. This is reinforced concrete designed to a crack width of 0.2 or less, and that's deemed inherently as waterproof. Reinforced concrete with a waterproof additive designed for us to 0.3 crack width is another type, and also sheet piles with fully welded clutches are another Type B solution. You may recall earlier that I mentioned one of the key considerations to reduce risk in the British standard was with the use of waterproofing additive in the concrete. There are 2 categories of waterproofing admixtures. There's hydrophobic and crystalline or hydrophilic. So hydrophobic pore blocking admixtures act as a binder, and they reduce the capillaries found in concrete. So the capillaries are small, almost little water transfer ports and small areas often found around the aggregate and things like that. And it enables kind of transfer ports and things for water to be able to get its way through. Now, a hydrophobic waterproofing admixture blocks these capillaries and dramatically reduces them, so no water can get through, therefore making it waterproof. On the flip side of things, the crystalline or hydrophilic systems are where there's a crystal additive and the structures are mixed in with the concrete. Now, when these come into contact with water, they react, and then they create a barrier to stop the water transfer through the concrete. Again, some people know these as self-healing. So in addition to the admixture to create the watertight concrete, consideration must be given to a number of things in the concrete design. We look at certain things such as the water cement ratio and the cement content and things like that. We need to remember that all concrete shrinks and cracks, and we need to make sure it's designed so the crack widths for watertight concrete for Sika are 0.3 mil or better and designed to BS EN 1992. Things such as pore layout, sequencing, compacting and curing can sometimes be overlooked, but these are essential and good concrete practice needs to be followed. These things are really vital. It's worth noting that the addition to BS 8102 about the implementation of an on-site quality assurance program, just to let you know, this is included with every Sika watertight concrete project. Sika Swell A, Sika Metal Sheet FBV, and Sika FLOWCHART are just a few names in our range of water bars and construction jointing methods. These must be considered in all construction joints, as any joint is high risk for water ingress. And again, we need to reduce or remove risk. Sika's product range goes from your standard hydrophilic water stop to a full PVC and elastomeric water bar to an injectable Sika FLOWCHART hose system. We have a solution for every application. Water stops come in a variety of forms and compounds. Now, the most common ones in the UK being hydrophilic, PVC, or metal. Now, elastomers are used for very high performing structures, and only a handful of projects use these every year. So the most comprehensive standard for water stops is actually the DIN standard. This is largely adopted in the UK, and it's a German standard. PVC water bars work using what's called the labyrinth principle. Given the rib profile of the product, water will actually run out of energy when trying to bypass this long before it reaches the internal side of the structure. The amount of ribs, the size of this product, is dictated by things such as joint width, movement, water pressure expected, concrete thickness, and things like that. Again, some water bar systems are custom made and need to be designed in-house. This is something we can do for you, but it just does take that little bit longer if a specialist water bar system is needed. But again, please contact us. We're more than happy to assist and provide guidance on the right product for you. Okay, moving on now to type C. We're going to mainly talk about cavity drain membranes. But type C solutions are split into two areas. Now, these are drain cavities, where a drainage layer is added to the cavity, kind of a drainage gutter, and this is to catch water ingress, and then it's managed out the building. And then there's also a cavity drain system, but you'll probably know these as what's called an egg crate system, as most people call them. So the principle of this system is very, very different to a type A and a type B system. So this is where a cuspated membrane is placed on both the walls and floor of the internal side of the structure, and from there it can deal with the water ingress. So this is collected in a perimeter drainage channel, and then it's drained to either a sump and pump unit in the floor, or it's gravity drained out of the building. There may need to be multiple sump and pump units or drainage areas dependent on the size of the project. Now, unlike other waterproofing methods, these don't stop the water ingress, but they manage it once it's inside through a series, as I say, of sumps, pumps and channels. And what it's there to do is protect the fixtures and the fittings of that internal space. Now, these systems are a great way to reduce risk. Now, instead of blocking the water ingress and moving it elsewhere, remember I mentioned that water always finds the path of least resistance? Now, this system lets it in and then manages it away from there. The most important part of a cavity drain system is maintenance. Now, this solution needs maintaining. This is typically a yearly service of all equipment and flushing out of the system, and without this, any guarantees present are actually invalidated. Now, access points in the floor and walls are required to carry out these tasks. They're often perhaps a little bit bigger than a double socket and can be quite easily hidden, but again, these are key to make sure that this can be flushed out. A cavity drain system is a phenomenal way to waterproof something, but you have to make sure that it is maintained and the system is not blocked, because if it is blocked and there is too much water ingress, the system will fail. Now, as these systems usually rely on sumps and pumps, there is going to be an ongoing electric cost associated with this. So it's not just the materials that should be considered. And again, this is worth discussing with the client during the design stage of the project. Cavity drain systems are used in new build and refurbishment. They're often used, though, as a secondary line of defence due to the ongoing costs of maintenance. Okay, so we're on the home straight now, and here's a quick run through of some of the key points that are worth remembering. The basement gradings as per BS 8102. The gradings range from 1 to 3, with 2 different types in the grade 1 category. These range from wet to totally dry. Grade 1A, wet, where seepage is tolerable. Grade 1B, which is damp from groundwater. There is grade 2, which is damp and damp patches from condensation is tolerable. And grade 3, dry, no water penetration, ventilation required and heating, and this is a habitable space. So once you know the grade for the area, or for the whole project, in fact, what you need to do is select at least one of the 3 protection types and maybe a combined level of protection dependent on the risk and the size and location and things like that. Now, combined systems need to be different types of systems, so type A and B, A and C, B and C. Now, there is an exception here where 2 type A systems can be used, but these must have different water resisting properties. So something like a pre-applied membrane, you could use that, and then an internal render system. 2 type A barrier membranes, as they're called, but they have different water resisting properties. So what you can't do is just put 2 layers of the same membrane on the outside of a project and say I have 2 lines of defense. Again, we can supply advice and guidance on that. As mentioned numerous times, waterproofing is all about reducing risk. At Sika, we offer multiple options in 3 types of waterproofing recognised by the BS 8102. So therefore, as a manufacturer, we're not biased towards a certain system. It's not a case of this is what we sell, so this is the best. We offer all systems. Because we do that, it inherently reduces risk because we know they're compatible. There's no split liability, and we're able to work on a whole project and not need to outsource anything. For us, it's 1 system, 1 supplier, 1 liability. Our aim at Sika is to work with you to get it right first time. Given our long history of products, our qualified experts in the business, we can provide a market leading solution and service with an unbiased view, as we do it all. To give a robust design is really important to us, along with technical, commercial and a buildable solution. Support through from the inception of the project to completion. Our on-site technicians are available to train and support through the progress of the construction phase, again to limit risk and make sure the performance of the waterproofing is at the desired level. And again, we have a team of CSSW qualified experts providing specification and design support. There is support from start to finish for this. So it's a great thanks from myself, and I'm sure from James and Pete as well in the chat box for your time today. I really hope you've enjoyed the presentation. Today isn't about trying to turn people into waterproofing experts, but just to give you enough knowledge and confidence to be able to know enough and know where to go. Most importantly, it's where to turn for expert support and advice. We're always more than happy to help you. We'll leave the chat box open for any more questions. Please also find key contacts on the screen now. Thanks again. Take care.